Okay, if I want to measure V R1, that means the voltage across R1.
Put your red or plus lead on A and your black lead on B.
Perfect.
Okay.
That means you have to know how to using equipment to measure it. Okay. So now I want to calculate the VB. Telling me. We don't care value, R1, R2, R3. We really care about the formula.
R1 times.
If you want VB, how do we calculate it?
V total minus VA.
I can say that to be E. Okay. So equal what? How?
Over B.
You're telling me the way.
VE minus VA.
What do you mean VE minus VA?
Oh no, my bad.
Who knows? What VB equal?
Current times R2.
E times R2. Then what?
Somebody said the current times R2 is the drop over R2, which is VB.
I say I want to calculate V equaling B. How do we calculate the VB? Make sure.
VE minus VR1. V total minus VR1. No.
What do you mean V total?
VE. Total voltage.
Okay, E. Minus
Okay.
what?
Minus VR1.
I understand, but that's not the way to calculate it. The handout I given to you, that's a summarized, very, very basic. You have to go over and over. Now, I want you to using I call voltage divider law. Okay, voltage divider law. So GVB will be equal E time R2 divide R1 plus R2. That's what we call voltage divider law. You understand the Ohm law, you can get I times R. I equal V E divide R. And R equal V divide R. First thing, you have to memorize the formula. Second thing, you have to memorize the unit. E means in voltage. I have to be ampere. And R have to be in ohm. That's the minimum thing technicians have to know. When you're looking into the circuitry, you know that's a series circuitry or parallel circuit. In a series circuitry, you get extra voltage divider law. Okay, if you get any question, just bring it up. Okay, now the current flow here. I1. I2. I3. What I3 equal?
It's 0.
What I3 equal?
I1 plus I2.
Who else?
Voltage divided by resistance.
No.
Well, first of all, you got an open circuit at the very end.
Yeah.
So no current is flowing through R3.
Perfect. The thing is it's open. Current cannot flow into the open circuit. So I3 have to be equal
0.
0. Okay? If I want to calculate the current I1 formula, we're just talking about the formula. We don't want to do calculation. I1, that means go through R1. Using the Ohm law,
Voltage divided by R1 plus R2.
come on. I1, current I1. You understand I equal V divided to R. If you're looking into the circuitry, what I1 equal?
In this particular circuit, since where R3 is at the end of R3, you have an open circuit, so no current is flowing in R3.
Right,
So
that's what I said here.
I know, but wait, I'm not finished, Mr. Pham. So then you're left with a series circuit with R1 and R2. So in series circuit, the current is the same. I1 and
Yeah.
I2 would be the same.
Correct. But what I said, tell me the formula to calculate the I1.
E divided by R1.
V divide to R1, correct. However, you have to identify V with V.
V at R1.
Perfect. Okay. If the current I2 VB okay,
Mhm.
Hey, Mr. Pham, I got a question.
go ahead.
On you showed us there how to get VB equals E times R2 over R1 plus R2. So would VA equal E times
Now VA, that means the same E. Doesn't matter.
There's no resistance.
okay.
LE, that's the same thing. Anything else, okay? Make sure it have to be clear to your guy before we can move on to the other thing. Otherwise, you get lost. Okay? Now, that one, okay? We get that for your guy to go over. When you see the signal sideways display on the oscilloscope, okay? That will be helping you to do your lab. Now, today, we're talking about diode. Okay? This is diode. This side contains P-type, N-type. N-type get the electron here, the hole here, okay? And basically, there's a junction here. So when you get more voltage applied, electron will be moving, okay? Moving this way. However, that's what you get a current. And we deal with the conventional current. Current have to be going from P to N. Okay? This is the middle between P side and N side. If they wider, that means electron cannot move it. So that's what we call a diode. And a diode can be built by a silicon diode or the germanium diode. You don't have to understand it much. Okay, physical here, we don't do anything with that. But we're doing this what? This is the diode symbol. On the P tie here to get a anode, and the other side cathode. Okay. Diode voltage VD. This is the VD. VD equal VA minus VC. That's what we call voltage across diode. Okay, so now when you're looking to the diode, you recognize which one will be anode, which one will be cathode. And the voltage VD across the diode, that means VD equal VA minus VC. Okay, so basically first ideal approximation. Okay, this is the ideal diode. What happened to ideal diode? VD equal 0 volt. That's the ideal. That never happened. Okay. Next one. Okay. Reverse bias and forward bias. Okay. Let's see. Ideal diode VD equal VA minus VC equal 0. Reverse bias. In this case, diode off. That's only telling you reverse bias, electron cannot move it. Diode will be open. Okay, that means no current flowing from A to C. Okay, open circuit. Okay, and this is a forward bias. That's telling you the current can flowing from this side A to the other side. Okay, so basically you have to deal with the diode. Is it the open reverse bias or it's a forward bias? What's the difference? Reverse bias, that means diode will be open. No current flow through it. And a forward bias, that's telling you diode closed and the current will be flowing from
Back and
anode
forth.
to cathode. Okay. Second approximation. This is basically ideal. We don't care. However, this is the forward and reverse. Okay. When you say the diode on, that means the conductor current. Then your circuitry have to substitute diode by the battery. 0.7. Okay. If they on, you want to solve the problem, you must substitute the diode by the battery. Okay. This side will be positive, this side will be negative. Now, for this example number 1, calculate given VD equal 0.7. Number 1, diode on or off. You have to tell me
It's on.
what you think. On. Why?
The anode is more positive than the cathode.
The thing is right here, you get 10 volt. If the diode on, basically, you have to redraw. Okay? The diode now, they will be look like plus minus 0.7 volt. You must be substitute the diode by the battery. Value 0.7 volt. Which side positive, which side negative. The thing is you get a 10 volt here. Higher than 0.7. So the diode will be on. Okay? The diode will be on. And when they on, you substitute the diode by the battery. Exactly like that one. Okay? We don't care about diode anymore. So, my question is, what V out equal?
0.7.
0.7 volt. The thing is when you want to measure the V out, you're using the meter, you connect high side here, low side here. Whatever voltage you get. Exactly when you want to measure your car battery, you connect high side to the red, low side to the ground. You can get a 12 volt. When you measure the voltage across the battery, you get that voltage. So that's why V out equal 0.7.
And Mr. Pham, didn't you say in the, when you first start off with the problem, you gotta determine the drop or something? I forget exactly how you said it, but you put 10 volts at the top and then you go 10 minus 0.7, and that's how you find out if it's open or if it's on or off. Can you re-explain that part?
No, that's a very simple thing. You get a diode, correct?
Correct.
Right here. So, if I give an example, I given here instead 10 volt. Now I given here 0.5 volt. What happened to the diode?
It's not on.
They cannot be on. The thing is 0.5 less than 0.7. Okay, the diode will be open.
Uh-huh.
By the way, in this case, diode open. If you measure V out, what you get?
You get 10 volts.
Now I'm talking about 0.5 volt right now. If I change it to 0.5 volt, okay, and let voltage less than 0.7 volt to turn on diode, So the diode will be open
Open.
Mhm.
here. So what do you think we out?
0.
0.5.
0.5. The thing is why? When they open, that means no current flow here, right?
Mhm.
That means no voltage drop across our limit. So the voltage this side and this side will be the same. Okay, so you already know diode off. V out equal V out equal plus 0.7 volt. How can we get the current I?
10 minus 0.7 divided by 1K.
Perfect. Okay. I equal. You know that will be 10 volt. That will be 0.7. So I will be equal 10 minus 0.7 divide 1K. Okay, the last question on that problem is V across R. That means V R, okay, equal I times R. I you already calculated. R you already know the value. Then that's why you're able to calculate the VR. Okay, any question regarding into example number 1? Try to clear understand. Okay. Exercise over. Not only one time you can memorize. You have to do it. Go over. Okay. And the question, example 1. Okay, now we go. Number 2. For that circuitry. Question A. Diode on or off?
Off.
Off. Correct.
Yeah. Off.
Why it off?
No current coming through
Ground
it.
is at 0.
Okay, the thing is the potential here. Across the diode, this side 0 volt, right?
Mhm.
The other side 5 volt. So they less than 0.7. The diode must be off. Off means open. Open. What we are equal? What we are equal? Your guy have to telling me. Maybe it's wrong. That's why you learn. Okay. By the way, this is the current. In this case, the diode off, that means you get to open here. What the current high you think they supposed to be?
The current is zero. No current is flowing because you got an open circuit. So when you put the leads, one on the ground and one where it says V out, you'll measure 5 volts, and that's what V out is.
Okay, that's correct. That means the diode open, so the current flow will be zero. Current flow is zero. That means the voltage drop across the limit equals zero. So the V out or V bias here the same. So V out what current I?
Zero.
Zero. What V voltage across R?
Zero.
Okay, first example, diode, second example, diode, any question, anything, bring it up. This is a basic for anything else later. If you cannot understand, then I can guarantee you get lost. Okay, they get two different types to make diode, silicon and the magnesium. Only the difference will be silicon diode they using 0.7 volt, the other one 0.3.
Are the germanium ever used?
What?
Are the germanium diodes ever used?
No, they're not using that frequently. Okay, this diode on or off?
Off.
Correct?
Yeah, the anode is at ground, which is basically 0, and the cathode is at 2 volts. So the cathode is greater than the anode, so it's off.
Okay. They will be off now. If they off, they can be look like A here, open, C here. That means when it's off. This diode on or off? One side connect to 3 volt, the other side 1 volt. So this is a VD.
Anode is greater than the cathode, so it's on.
VD equal VA minus VC. Two volt, but 2 volt greater than 0.7.
7.
So we can say they will be
On.
on. Okay. The thing is, if you looking into the diode, you don't know they on, they off, you cannot solve any problem. Okay. I want to calculate the current. And V out. Okay, when you working with the circuitry with the diode, you must know diode on or diode off. Okay, If you don't know, cannot solve the problem. Okay, if you're looking into this circuitry, you're telling me diode on or off?
On.
On or off?
It's on.
Perfect. It's on. That's what I said. So I have to talk to me, okay? You try to get more active in the program. Now, in this case, I say diode on. Why I say that? The thing is this side. The thing is this side 5 volt. This side ground. So that greater than 0.7 volt anyway. So the diode will be on. Okay, now redraw this circuitry. Telling me, how can we draw the diode? You cannot leave a diode on the circuitry to solve the problem. You have to substitute the diode by what?
The battery.
Battery. By battery. And that battery will be how many volt?
0.7.
0.7. Instead of diode, now you draw the battery. Positive, negative. Blood minus value 0.7 volt. Okay, so now you can see V out equal the difference between 5 volt and 0.7 volt connect in series. 5 minus 0.7 given you 4.3.
Hey, Mr. Pham, and that's because the 0.7 battery post is a plus connected to the 5 volt battery post, which is a plus, and you can't allow that, right?
You mean the positive 0.7, right?
And the positive 5. Yeah,
Mhm.
you can't add them up. They got to be subtracted, correct?
Yeah, the thing is that talking about power supply, okay, connect in series.
Right,
They get the same positive, right?
right,
They have to be different.
right. So that's why you have to subtract them.
Exactly.
Okay.
Okay, you get current I. Equal V out. What?
4.3 divided by R1.
Yeah, we don't care what you get. Make sure law. Okay, voltage have to go with the ampere and ohm. If you get kilo ohm, you have to converting to the ohm. Okay. Now you have to help me solve the problem. Example number 3. Number 1, diode on or off, and current I. Current I means the current flow here. First thing, you're looking to the circuitry, tell me diode on or off.
High potential to low potential.
The diode on or off in example number 3. Oh no, now you telling me the voltage this side how many volt?
5,
5. The other one how many?
8,
That means the voltage on this side higher than positive in here, 5.
So
So
the
the
diode is the diode's off,
diode must be
off.
off.
up, okay, ground,
Now, what do you mean drop? Off mean out, open.
Open.
up.
That means you open right here.
Mhm.
So basically, Mr. Pham, we got 8 volts minus 8 volts is larger than 5 volts.
Exactly.
And the 8 volts is on the cathode side, and the
the
5
five-
volts is on the anode side. So the cathode is greater than the anode. So therefore, the circuit is open.
What about you try 13? Positive, positive, positive 5, positive 8, B 13.
What is? Okay. You have to telling me this side around 5 volt, correct?
Yeah,
The other side here, 8 volt, correct? Now, VD, diode voltage, VD equal 5 minus 8 minus 3.
3, that one I got.
VD less equal minus 3, okay? Then VD less than 0.7 volt. That's why they will be off. If you want to set the diode on or off depending on the VD, VD higher than 0.7 volt, diode on. If you say diode on, now you have to substitute the diode by the battery with the value 0.7 volt. If VD less than 0.7, then the diode off. When diode off, you have to substitute the diode with the open circuit. That is the key point to understand the diode. Number 4. Diode is forward bias or reverse bias. Forward bias means on. Reverse bias means off.
Six.
You get 50-50, right? On this problem here, you're telling me diode on or off.
The total 66.
Okay, now, this is around 0 volt. This is a negative here, minus 100. Tell me diode on or off.
Diode on. 0 volts is a bigger number than minus 100.
Exactly. So that's why I diode on. Make sure you guys get any question confusing, whatever, bring it up, try to clear. Okay? Again, when you're working with a diode circuitry, if you don't know it on or off, you cannot solve the problem. That's the first thing. Must know on or off. Second thing, if it's on, is that diode now to substitute by the battery plus minus 0.7 volt. Then you can solve the problem. If it's off, substitute diode by the open circuit. That's a very, very basic thing. Okay, up to this point, any questions? Now we go to another. Before we can go into the Zener diode, you must be understand the diode. Okay? This is a symbol for Zener diode.
On.
Okay? This is a symbol. Now, they will be working like that one. Let's see. Major application for Zener diode is a type of voltage regulator for providing stable reference voltage for use in power supply, voltmeter, and other instruments. Okay. Now, fourth thing, Zener diode, they can be break down. Right here. Break down. Now, when you say the diode break down, then you substitute diode by the battery with the value VG. That means the diode Zener voltage. I can give you an example. When you go to the electronics store, you want to buy Zener diode. Then they are asking you what voltage you want. That's what they're talking about, VG. You say 5 volt. Okay? Then they can sell it to you. If you don't know what the breakdown voltage equal, cannot get it. So when you say the Zener diode breakdown, then substitute by the battery. Okay? Like the battery 5 volt. You understand in your computer, they're using the 5 volt power supply. So before connect into your computer circuitry, they have to get the Zener 5 volt. Why? The thing is, if any voltage higher than 5 volt, they break it down. That means you will be get 5 volt. That try to protect your circuitry. Sometimes the input coming in 10 or 20 volt. If you not protect, they will be cooked your motherboard in the computer. So we're coming up with the first one. We're talking about Zener breakdown. Again, I can give it you. If you get right here, it's 10 volt. And the Zener breakdown is 5 volt. So they can forget this one. They will be 5 volt. And the Zener breakdown voltage, depending on what you need. And you buy, you have to tell. I want the breakdown voltage 10 volt, 5 volt, whatever voltage. That is, you say, Zener breakdown voltage. Second one. Now, Zener not breakdown, they also can working like normal diode. Okay, they're telling you the voltage difference higher than 0.7. They just on. Okay, or they can be off if the voltage less than 0.7. Okay, so when you see in the circuitry, you have to recognize this is the Zener diode. And what is Zener voltage? Now, that's what. For this circuitry here, okay, that's what you get Zener. The question is, what VL equal? Zener here, they gave it to you 10 volt. that will be telling you what we are supposed to be.
10 volts.
How come you get 10 volt? Again,
You get 10 volts because the the supply is 20 volts and the zener is regulated for 10, and that's the maximum you're allowed to have is 10.
that is, you can get a right answer, but it's not good explanation. So now, if you hit into this kind of problem, what can we do?
Explain.
Okay. Now, first thing, you suppose no zener here. Okay. What we out?
Be out, it'll be 20 volts.
20 volt.
Mhm.
Okay. So now, if you get the zener, and zener will be 10, any voltage higher than 10, they cut it out. So that's why voltage now will be
10.
10 volt. That's why you have to know the way to solve the problem. Logically, okay?
So Mr. Pham, what you just did, you took the zener diode out first, correct?
Okay, right.
And then your next question was, once you took the zener diode out, then what is the output voltage minus the zener diode?
What is the output
Without
voltage
without
without
the zener,
zener? You said 20, right?
correct?
And now you said 20 higher than zener 10 volt.
But the zener is regulated for 10,
Right,
and we don't want a voltage higher than 10.
right. So
So
that's why
therefore the output must be 10 volts.
they will be breakdown.
Right, breakdown.
So that's why in here, hey, what if we out? If we in equal 20, the answer will be 10 volt. Zener breakdown. Okay. Now, what is the current through R? Okay. I equal 20 minus 10 divide 220. So that's solving for question 5A, 5B,
22.
and the question.
Explain.
If I try to teach you guys still cannot follow it, understand it. Forget about to be a technician. You understand instructor, maybe they can understand, they know. However, how do we How do they teach it? The teaching will be a required different way. Okay, number C. If we in now 5 volt, okay, they say now they will be 5 volt
-5.
minus 5. Okay, thank you. What
So
we
then-
out?
So you take the Zener diode out, correct? And if you take,
Yeah,
if you
yeah,
take, if you take the Zener diode out, then you have -5 volts up top.
right.
But the Zener's regulated for 10 volts. So I don't, do you go 10 -5 or you just say -5?
Okay, now, again, when you're working with a Zener diode, first thing, is it breakdown? Okay? If not breakdown, then they can working like normal diode. We already learning diode. That means they like the battery, this side positive, this side negative, value 0.7. So now I substitute battery by -5. Okay, they want to know what we out. Who know? What is V out? Now we have to deal with the Zener.
You.
Zener breakdown or no? Not breakdown.
No, not in breakdown.
The thing is only -5 volt. Okay, if it's not breakdown, they can be working like normal diode. They can be on or they can be off. Off means open. Okay, so
So
tell
then,
me in this case, which one? Not breakdown for sure. And now you have to deal with a diode. Is it they on or they off?
Mr. Pham, if I could, before I give you the answer, can I ask a question?
Yeah, go ahead.
Okay, so you got -5 volts and the Zener's regulated for 10 volts. So the cathode part, because it's like you operate it like a regular diode now. So the cathode part would be -5. Is the anode part 10 volts? I'm asking you.
Okay, now you said you get -5 volt.
Correct, right there.
It's not higher than 10 volt.
Right,
So Zener not break down. That's the
Right.
first thing. Okay. They not break down, right?
right.
Now you have to tell me the diode on or off.
I know what it is. Okay, so if you got -5 volts right there, but ground is 0 volts and 0 is bigger than -5. So and the diode is being operated like a regular diode now. So now it is the diode's on. The diode's on because 0 greater than -5.
Okay, diode now will be on. The thing is 0 volt and another one -5 greater than 0.7. And diode on. Substitute diode by the battery. Negative here, positive here. So V out will be equal correct?
Correct.
Okay, so now you get this side will be minus and they want calculate current I. I will be the difference, okay, between minus 0.7 minus to minus 5 divide to 20. That's how do we calculate the current I.
0.2.
Okay, the thing is make sure, after we're done, I try to upload the video tonight. You guys have to go over. Next time meeting, hopefully this is not a problem. Okay? I asking you question, you able to answer to me. Now try to this one. For the circuit cell, zone 4, no load RL. Right now we're talking about no load, that means forget that. So now you already see the Zener. Again, working with the Zener diode, you have to come up with they break down or they just on normal or off normal. Okay, first thing the answer will be for this Zener, they break down or not. That's what you are able to get that first.
Zener breakdown equal 12 volts.
Again, for the Zener, first thing, we don't have a Zener here. What we out?
V out is 24 volts.
Okay, now that's what I first step you have to do. Okay, if no Zener, we out 24 volt. Okay, then with Zener,
24 is larger than 12.
12
and
volt.
it's- And the Zener is
Okay.
mandatory for 12 volts, right?
Then Zener breakdown.
Zener breakdown equal 12.
So that's why V Zener equal 12 volt. That means V out. IG. That means the current IG here. Same thing, the current I total.
So you're doing the IZ first, right, Mr. Pham?
IG I total, that's the same.
Okay, then it's,
The thing right now, we don't have a load.
okay, then, since the output is equal to 12 volts, then,
That
Then-
means here will be
then
12.
it's 24, then it's 24 minus 12 divided by 470.
Perfect. I total will be 24 minus 12 divide 470. That's how we calculate the current. Okay. Also, they asking for I load, IL. That means the IL right here.
That means the load is put back in the circuit, right?
No,
No?
no load IL.
Oh, IL with,
Okay. You see, they say no load.
then it's zero, because if there's no load,
Right. That means the current flowing here. And VR we already calculated. IG I also calculated. Now, with the load, okay, with the load, same thing.
same thing, because
That
Is it-
means no. Okay, now telling me now you get the load, the new circuit. First thing, again, you have to know the Zener breakdown or no.
yeah, the Zener's in breakdown.
I don't know. How do we know? How can we solve that problem?
I did.
Again, okay, one more time. In order to see the Zener breakdown or not, first thing, remove that. No Zener first. Okay? What we out? Okay? If no Zener, V out equal if we don't have a dead Zener now, what V out equal? Now we get a load, okay?
It's 12 volts, ain't it?
How can we calculate the V out? Telling me how can we calculate the V out? Who knows? Telling me the formula.
V out went out, the load. V out.
Now you can get only
Can get it.
that one and that one. Did you know? I want calculate the V out.
So then,
Like
How do
you,
we calculate it?
voltage is current times the resistance, so you know the current, right? And the resistance is RL
RL,
and R.
How can we calculate it?
look like zip. Zip.
Using what formula?
Ohm's
Divide.
law.
Divide it.
You have to using the voltage divider law. Again, I already showed you this kind of circuitry to register in here. Voltage divider law. So V out will be equal 24 volt times
490.
IL divide R plus RL.
Yeah.
Voltage divider law, please.
24 times 490 divided by 47.
Equal 24 times IL 490 plus 470 plus 49 equal what? Let's see. I get 12.25. That means without the zener, okay, the voltage in here is 12.25. So the diode zener breakdown or no?
Yes, it's lower.
Well, 12.25 is a little bit over the 12 volt Zener breakdown.
Perfect. The thing is the V out equal 12.25 volt compared to zener only 12. So zener breakdown. So they're telling you output now will be 12 volt. So if I want to calculate the IL, I load IL equal V out divide RL. Okay. And then they calculate the IG. How can we calculate the IG? Okay, you have to calculate the total IT. Okay. IT equal 24 minus 12 divide 470. Okay. You get the current IT here. When they go here, when they go in here, you already know the load IL. Then IG, I total minus IL. What I recommend, you have to go over, not only one time, too many times. Hopefully you can understand. Okay. Next meeting, we will be get the quiz regarding diode and the Zener. Okay. Only the different, minor different. I hope you can get through it. Any question up to this point? Any question, anything? No?
Tiene que superar frente a mí.
The thing is, if you done for the level DC fundamental, and next step you will be working on the diode. Okay? The circuitry will be different from DC fundamental. That will be a semiconductor. Okay? And also, I recommend when you're working on the lab board, if you not quite know how to do, ask the lab instructor. Okay? If I in the class, you can ask me. No problem. Okay? You can ask me anything. Assignment. Okay? And also the quiz, try to make sure it's clear for you. Okay? If you know, you understand, you know how to do what to do, that you can solving a lot of problem done quickly. Okay? I don't want, you don't have to be in the class all the time, but get nothing done. Okay? I want the job done. On the any related to the lecture, you have to do your job, you upload it, we check that. On the left vote, you working on the recording into the server. Everyone, every time. Okay? If you get it done quick, you okay. So, Any question, anything? Hopefully next time, when you try to do the quiz for diode Zener, also, you can get it done quick. So, do you have any question, anything?
Professor Pham,
Yeah,
did you by any chance posted the grades from the last quiz?
what for the last week? The quiz?
Yeah. Yeah, did you, is there anywhere that I can
I
find?
I already get the answer. Some people uploaded. Okay? Will be let you guys know.
Oh, okay. Thank you.
Some student upload the file without anything. I don't know.
Well, I just want to see how well I did on.
Yeah, only one student get A. Most get C. Okay?
Wow.
But I will let you guys know.
Thank you.
Yeah, just see if you understand very easy. Okay? So I will try to upload this video tonight. Okay? If you're still confusing, if anything else, just watch the video and you can let me know any questions you want. Okay?
Well, the thing, at least with me, is that I don't have a background in electronics, so I feel like sometimes it's just you start on a subject and start in a way that there is no background information or any where like you build it up.
Okay. I
So
understand.
I get lost, but
Yeah.
that's I try to do studies on my own, but I'm usually I think behind.
Okay. I understand. I try to think for the most students know nothing about electronics. We start at the beginning. However, what I want to make sure you have to read the handout, okay? Go to the video over. That is the way to study. You reading one time, 2 times, 3 times, you cannot understand. However, 5 or more, 10 times, up to a certain point, you understand everything. Okay? That is the way you study. Have to go over, memorize, okay? Like diode on, what? The voltage have to be, VD have to be greater than 0.7 volt. What is VD? VD is the difference between voltage at the anode and the voltage at the cathode. If they on, and now to solve the problem, then you have to substitute the diode with the battery value 0.7 volt. If you say the diode will be off, you substitute in the circuitry is open. Then now you can solve from that. Okay? But this is just the first day. Still too many confusion. I guarantee that. Next week will be get better. Okay? If it's not, so good night, everyone. Okay? We'll see you again.
Good night.
Good night.
You know, people mostly like,
Good night.